Hello all, let's start section 2.9. Section 2.9 is linear approximations and differentials. What does it mean, what we do in this section? In this section, actually, we are discussing that if I have a curve, let me draw. For example, if I have this curve, let's say this one. I have a curve like this. And I have a point on this curve, which we usually name it in your book, point A, right? And let me draw also the tangent line to this curve. For example, this is the tangent line at point A, right? This is my tangent line. Let's name this tangent y equal Lx because it's a tangent line, correct? And I have a function y equal f of x. What I do with linear approximation, look, if it's really easy on this curve to calculate how much is the value of A at this point. The value of A at this point is definitely, this point will be A and f of A. But if I want to calculate another point, let me use another color, for example, this green. Let me have another point here. If I want to calculate the value of that point, which is really, really close to the value of A, it is not easy to calculate that value on a curve. Or another point maybe here, or another point closer to this. It's really not easy. Sometimes even it's impossible to calculate that value on that point on a curve. What we do instead, we use linear approximation. What does it mean? Look, if I zoom my curve a little bit, zoom, if I zoom it, zoom, zoom, you see now my computer cannot zoom anymore. Even you can see that you see your curve as a line. If I could zoom more, you could see that your curve at the point A actually is looking like a line, right? If I zoom, you can see that at that point, your curve becomes like this, almost like a line, right? We call this process linearization, correct? Now, I gave you two formulas, one for linear approximation, how to find that point on a curve, and the other one, linearization, correct? Which is actually the tangent line, correct? Remember, you have this formula, y minus minus y1 equals m times x minus x1. That is the formula to confine a linear equation, correct? We call it slope point formula. Now, in this formula, look, if I solve it for y, I can write this formula as a y equals y1 plus m times x minus x1. What is the slope of the tangent line? Your m is actually f prime a, right? You learn this in limit, you learn this in derivatives as soon as we start, that the slope of the tangent line, f prime a, is actually m, correct? Instead of y1, I can name it, my y1 is actually f of a, correct? And instead of x1, I have, look, this is your y1 and this is your x1. Instead of x1, I have a. Let's rename, let's put everything here. Then if I write, and you know y is equal f of x, instead of y you can write f of x. Then in this equation, I can write f of x actually equals f of a, which is y1, plus m. Instead of m, I can write f prime a times x minus x1. x1 is what? A. If I change this equation sign to approximation sign, why approximation? You see, I told you the reason. If I zoom, I can change my curve to a line, right? That's why we put, it's almost, approximately, my curve becomes like a line. This formula that you see here, and I boxed it for you, we call this formula linear approximation. And if I, instead of f of x, if I write Lx, which is my tangent, right? Tangent line, Lx equals f of a plus f prime a times x minus a, I will call this equation linearization. Linearization. Only and only two things to remember. F of x approximately equals f of a plus f prime a times x minus a. We call this one linear approximation. Soon I'll do an example and you learn the meaning why we call it. And L of x equals f of a plus f prime a times x minus a. We call this formula linearization, correct? Now let's do an example. In this example, you will learn more what is the meaning, why we are doing this. Example number 1, I'll copy this example from your book. Find the linearization of the function. Let me write the linearization of the function f of x equals square root of x plus 3 at a equal 1, at a equals 1, and use it to approximate the numbers square root of 3.98 and square root of 4.05. Correct? First, they're asking you find the linearization of the function. To find the linearization of the function, your formula is Lx equals f of a plus f prime a times x minus a, right? That was the formula that I just gave it to you. Now look in this formula. You need f of a and you need f prime of a. A is given to you, a is equal 1. And also f of x is given to you. F of x equals square root of x plus 3. First thing to do, I will find f of a. Your f of a means f of 1. F of 1 equals a square root of 1 plus 3, which gives you square root of 4, which is what? 2. Next thing that I want to find is f prime a. Everyone knows how to find the derivative of this function, right? Look, instead of f of x equals a square root of x plus 3, I can write a square x plus 3 to the power of 1/2, which is the same thing. Now, it's not a class. I cannot ask you a lot of questions, but I want to tell you here that you are using here the chain rule, correct? The derivative of outside times the derivative of inside, correct? To find f prime x or f prime. First, you have to find f prime of x. Then after that, you have to find f prime of 1, correct? Which is f prime of a. Let's find f prime of x. F prime x equals the derivative of outside. It means 1/2 x plus 3 to the power of 1/2 minus 1 gives you negative 1/2 times the derivative of inside. What is the derivative of inside? The derivative of inside is 1. Correct? The derivative of x plus 3 gives you 1. Or you can use the U method that I just teach it to you when I taught you the chain rule. But I did this straight here because it's a really easy function, correct? Let's simplify this a little bit. Then f prime x equals 1 over 2 to the power of 2 times x plus 3 to the power of negative 1/2. When you bring it to the denominator, it becomes a positive 1/2. Correct? Or you can write this one as a f prime x equals 1 over 2 square root of x plus 3. That is your f prime x. Now, when a is equal 1, then f prime of a, which is f prime of 1, equals 1 over 2 square root of 1 plus 3, which gives you 1 over 2 square root of 4, which gives you 1 over what? 4. Now, I have all the values that I need. I have f prime of 1, I have a equals 1, and I also found for you f of a, which is 2, right? Using these 3 values, then I can write Lx equals f of a plus f prime a times x minus a. Then I can say Lx equals f of a. F of a is 2 plus f prime of a, 1/4 times x minus 1. Simplify. Lx equals 2 plus 1/4 x minus 1/4. L of x equals 2 minus 1/4. Look, 2 plus minus 1/4. If you can't see it this way, right? Put this one, x over 4 first. Now, plus 2 minus 1/4. Here, you need common denominator. Common denominator is 4 times 4 times 4. Then Lx equals x over 4 plus 2 times 4 gives you 8. 8 minus 1 gives you 7 over what? 4. That is the formula for the linearization. It means, what does it mean? What is the meaning of this Lx? Now, the other one is f of x approximately equals f of a plus f prime of a times x minus a. Now, f of x is given to you. And the second part of the problem, f of x is given to you, and also you know this part. This part is this equation. This part is this one, x over 4 plus 7 over 4. Now, I can write the square root of, how much was there asking you? To find the square root of 3.98. The square root of 3.98 approximately equals x over 4. Now you have to know how much is x. Look, this part is tricky. If the function was f of x equals a square root of x plus 3. If a square root of x plus 3 becomes a square root of 3.98, then if I solve it for x, how much is x? You have to find first the value of x. If you square both sides, the square root goes away. It gives you x plus 3 equals 3.98, or it means x equals 0.98. Subtract 3 from both sides. That's my value of x. Let's plug it here. Then 0.98 over 4 plus 7 over what? Over 4. The square root of 3.98 approximately equals, just simplify these two fractions. And if I simplify these two fractions, it gives me 0.98 plus 7 gives you 7.98 over what? 4. And if you want to change it to decimal number, it gives you 1.995. It means the value of square root of 3.98 approximately is 1.995. You see, using the linearization, it's really, really easy to find the value of a point. But if I want to find this value on a curve, maybe it's also totally impossible because I don't know how to calculate it on a curve, correct? Part B of the problem, they give you another square root, the square root of, I think, 4.05. Look, a square root of 4.05. I let you to do this. First, you have to find if a square root of 4.05 is equal to the square root of x plus 3. It means x plus 3 equals 4.05. And if you subtract from both sides 3, it gives you x equals what? How much? 1.05. Use the same formula and this formula, and you can calculate how much is the value of square root of 4.05. This was all about section 2.9. I will stop the lecture here and see you all in chapter 4.